Hi, we're Team Adaptive Cycle, a multidisciplinary senior design team from the College of Engineering. We are working with our client, Scott Roseborough, to create a more user-friendly adaptive cycle. Current trike designs on the market have many problems that reduce functionality and cause frustration to the user. This includes trikes being too large to easily transport in a car, unable to maintain pace with other bicycles, difficult to transfer into from a wheelchair without assistance, and overall exhausting to use.
This is a video of me riding an example trike our customer allowed us to borrow up a hill. As you can see, I am constantly pedaling to keep the trike moving forward. It is frustrating not to be able to coast at all to give your arms a break.
Our definition of success for this project comes from our customer's expectations of the project. Our customer built a model of a possible solution to our project. His goal for us was to create a functional prototype that is more complete than the prototype we were provided. To create a successful prototype, we need to address the 4 key problems of current design solutions.
To solve the problem of fitting the trike into a car, we designed it to be easily split into 2 pieces. These parts can then be easily packed and stored together. To make the trike easier to get into, we matched the height of the seat with that of a standard wheelchair. Because this type of trike is powered by the arms instead of the legs, it's difficult to keep up with traditional bikes. To solve this problem, we included an e-motor assist to help put less strain on the user.
A challenge that came up early on in the design process for our group was that if we attempted to collapse and fold the bike for storage, it created slack in the chain, causing it to fall off the trike. In order to solve this problem, our team decided to use a 2-piece design to avoid much of the folding and instead use 2 chains, one for each section of the bike. Another design challenge we encountered was designing the steering mechanism. This was a challenge because 2 wheels in the front of the trike required a more complicated design to steer. We ended up spending multiple meetings adjusting the geometry of the mechanism to make sure it turned appropriately. As a team, we wish we would have started this sooner to avoid being held up.
A functional prototype is the goal for the next semester and is currently a work in progress. We have been machining parts of the frame and have a plan to complete the build of the trike by April 2021. The CAD model shown here represents what we hope to have to create by the end semester. We'd like to thank our client sponsor, Scott, for taking the time to meet us, our guide, Art Nora, for support, machine shop staff for helping us manufacture our system, and our Community Bikes for their donation of components. Visit our project website linked on this page to see more about how our project turned out.